Hello, Assalamu alaikum friends, this is Mohammed Inam and today we have a Leibniz rule of differentiation under integral sign. The statement of this rule is this one. This statement or this rule is very useful in integral equation. When we use integral equation or conversion of differential equations into integral one, we need this rule. So in this video we will try to prove it. Okay. First of all, for this proof we need some basic result like fundamental theorem of calculus. We know that a to b f x comma t dt is equals to a capital F. This capital F showing the function which after integration where x comma t a to b, which is equals to, by fundamental theorem of calculus, f of x comma b minus f of x comma a. So let's say this is our u equals to integration a to b f of x comma t dt. So let's say this is our equation number 1. Now taking derivative of u with respect to x, same here, derivative of this function f of x comma b minus derivative of this function f x comma a. Now we know that the b and a both are function of x, so by total derivative we can say that this thing is equals to d by dx f x comma b plus db by df by db x comma b times db by dx, because this b is a function of x and this is the total derivative of this thing. Let's say equals to d by dx of f at x comma b. Similarly, we can make a result for this one. So the derivative d by dx of f x comma a is equals to, first of all, derivative of f with respect to a x comma a times dA by dx. For sake we can say that this is a partial derivative plus the derivative of f with respect to derivative of x at x comma a. Now we can put this both result into equation number 1, or here we can put this both result into here and we will get, first of all this result d by dx f x comma b plus d partial f by partial b times db by dx, negative sign, and partial f by partial a dA by dx, negative df by dx. So here we know that d by dx integration f of x dx is f of x. So this is very fundamental result. So I am using this result up to here, this one. So this will be du by dx is equals to f x comma b of x times derivative of b with respect to x and negative of sign a function x comma a of x dA by dx, and these two results we can say that The last two results we can say like this one: integration from a to x, b to x, f df by dx, x comma t dt, because this can be written like this one. Here u was basically u was the d by dx, u was just nothing but a of x, b of x, f x comma t dt. So we have done. This is the proof of this theorem or rule. Here we have proved this result. So guys, we have done this rule. Now the corollaries for this rule. Case number 1, let's say a of x is a and b of x equals to b. Both are constant. If both are constant, then this rule will be changed and turn into just this one, and this both terms will be 0. Why 0? Because here we have a derivative of b with respect to x. If b is constant and a is also constant, then derivative of these two terms will be 0. Then these turn the rule into just in this form. Okay, now case number 2, where a of x is just a means constant and b of x is b of x, a function. So if lower limit is constant and upper limit is variable or function, then this term, the term here, this term will be 0, because here a is constant, then derivative of a with respect to x turn this term into 0. The remaining part will be this one if upper limit is variable or lower limit is constant. And the last case, case number 3, if a is a function and b is just constant. If this one, then this term will be here and this term will be 0 because of the derivative of b. If b is the constant, then this term will be 0. The remaining part of the result or theorem or rule is just this one. Now let's look on example. So guys, here is an example about the Leibniz rule. We can use here a Leibniz rule. How? Let's say this is a statement of the Leibniz rule where lower limit is constant, upper limit is variable, same like this one. So from this information we can rewrite this into this form. First of all, equals this term here, a function f is this one, then this I can write this sine x plus y times derivative. First of all, this is at x equals to xy, and what is b? B is x and y. We need to find the derivative of xy with respect to x. So we have done with this term. Now for this term, first of all we need a derivative of sine, then integration 0 to xy. The derivative of sine is cosine x plus y, and dt, it means dx. We have done. We have taken derivative with respect to y because the given derivative is with respect to y. So we have done this with these terms. Now simplification for this one is sine xy plus y, and the derivative of this term is just x. Now integration of cosine is sine x plus y, and we need to take at x equals to 0 from to x equals to y. Then this term can be written as sine xy plus y times x plus sine xy plus y minus sine y, because at 0 this will be sine y. Or simplification can be give us the results x plus y sine xy plus y minus sine y. So we have done. with the derivative of this integral. So guys, you have seen that from the Leibniz rule we can find the derivative under integral sign in very easy manner, and this rule is very useful in integral equation. In next video I will upload a video about multiple integrals convert into single one. So for more interesting video, kindly subscribe my channel. Thank you.